Dear ladies and gentlemen, let me to start today's webinar. My name is Jaroslav Navratil and I am Technical Director of IDEA StatiCa company. It is my pleasure to welcome you to IDEA product webinar on modeling of prestressing in StatiCa RCS, which is a reinforced concrete section program. Main part of my presentation today will be a live show of the program, which I complemented with a PowerPoint presentation to explain some background. You can ask your questions. Actually, you can write it down into the chat of GoToMeeting, and we will answer the questions after my presentation. We also make a recording which will be available for you to download. So I will start with the presentation. Actually, the topic came from you, from the customers. They asked our reseller ML Peltenburg how to input the data into action stages. Part of the program. You see these action stages of the program, and how to input the data into this dialog, either for the option calculate or user-defined input. That's why I decided to make one example from scratch, and I will explain it on the way, and I will also give you some theoretical background on that. I started RCS program from IDEA StatiCa as a new project, and I can press new project. I will select Dutch Annex, and I will select section type prestressed cross-section. After that, we generate the project, and you can select from these database sections one of the sections. I selected eye-shaped cross-section with haunched flanges, and we can modify the data, the geometry of the section, and after we do it, we have it done here. I will keep the material C3037 in spite of the fact that I would probably design a better concrete grade. Then we can continue in the navigator to the next position, prestressing, and to input the prestressing you have to run a reinforcement editor. This editor serves for input both tendons and non-prestressed reinforcement. So we start with tendons, and I select tendon on edge, and we can select the material. We can also adapt the data. For example, this is number of tendons. I want to have 3 tendons, and this NS is number of strands in one tendon. I will select 7 strands. Then my edge cover will be 60, also left and right cover 60 millimeters. And the duct was calculated from the area of the tendon. I will increase it for 45. That's it. And when we are finished, we can press OK, and we can see the tendons in the ducts, post-tangent tendons. Next chapter is design member. We can define exposure classes. I want to have XC3 for carbonation and XD1 for chlorides. We can also adapt the data here. But the more important is to input proper construction stages. We have some default data here, which I want to change. For example, the date of prestressing will be 5 days, which is an equivalent age. And I also want to add one, I would say, construction stage, but actually this is a stage in which we apply the loads, because we are in sectional program now, so there is not possible to speak about construction stages of one cross section. So we will have it as a additional load. You can see that at 5 days we have pre-stressing, and I can also put down here the P as pre-stressing and TG as additional dead load, or G1 possibly as additional dead load. So, and also we can adapt in finite time, which will be 100 years, and now we have it. We want to see it here in this dialog. Then when we switch into different rows, we see the cross section, which is useful especially in case of composite sections. After we have it, we can go to action stages, and now we have 2 possibilities, and that was the main question you raised. We can select 2 options, either calculate or user input and import. This part is related to determination of initial state of cross-section, and the tooltip tells you that the initial state of cross-section is calculated automatically based on specified internal forces and pre-stressing. Specified internal forces are in this table, and again the tooltip tells you that it is the increment of permanent load, characteristic permanent load used for calculation of pre-stressing losses and definition of initial state. Then the pre-stressing is defined in this table via tendon stress, either after short-term losses, or you can estimate the losses by factor, or you can input the stress after long-term losses manually. I will select this second possibility to define stress after short-term losses, and the effects of the pre-stressing is calculated automatically. You can see normal force and bending moment based on the position of the tendons and the stress defined in this table. But I mentioned initial state several times, and I also read the tooltip, which tells us what it is, but I haven't explained it yet. So let me to switch into the presentation, and we go to this next slide, which explains the principle of initial state method. Let us see this explanatory picture of axially loaded member. The member is post-tangent, and at the beginning usually we have dead load, I mean self-weight, applied on the member. Self-weight and also post-tangenting actually acts on weakened cross-section. You can see that there is a duct in the cross-section which is empty. On the other way round, this additional dead load and live load is usually applied on transformed cross-section. Therefore, transformed cross-section resists these loads. This is the problem of post-tangent concrete, which sometimes is solved via decompression state and by simplified method. But we implemented a better solution in our software, which we call initial state method. Actually, the history of the load N, G0 and PA and G1, and also the effects of creep and shrinkage are results of a structural analysis. If we calculate, for example, time-dependent analysis in our BEAM program, we calculate these effects automatically, and these effects will be taken as an initial state stress of the cross-section for the checks, for the assessment of the cross-sections. So we can make such vertical line in between these three first cases and last one, and on the left hand side we have a construction stages in which we apply permanent load, pre-stressing, and we calculate creep and shrinkage, and on the right hand side we have the application of variable load, which is added to the cross-section, which is at that time in a certain state of stresses. You can see it on the next picture, especially for composite section. It is very important. The long-term effects, which means, I will repeat once again, the effect of dead loads, pre-stressing, creep and shrinkage, aging, and similar effects, are taken as the initial one. So you see nonlinear distribution of initial stresses, and we add the variable effects acting on the cross-section. And then we use nonlinear method to analyze this cross-section with respecting the different starting values of the strain and stresses in each fiber of the cross-section. Actually, in this case, in each layer, if we have single bending. This method is very useful, especially in case of composite pre-stressed sections, which probably is not possible, in which it is not possible to use these simplified methods via decompression state. You would hardly be able to analyze the section in the way that internal fiber would become critical or I would say governing for the ultimate limit state, or of course for serviceability limit state it is quite straightforward, but even for ultimate limit state, it can happen, especially in case of composite pre-stressed sections. So now let me go back to the program, and you know what initial state is now, and we can input it. As I will repeat, this is effect of characteristic increment of characteristic permanent load. So let me to add here at 5 days 2,500 kilonewton meters as the initial effect. Actually, at that time I will put 0 back. You see that this table is changing. If I say 2500, then I have changed all the calculation of the losses due to elastic deformation and also long-term losses. In this table we have all the data related to losses and also some intermediate data related to creep, shrinkage, and other nice information which you can check. So once again, this table must be filled in. We use it for the calculation not only pre-stressing losses, but also ultimate limit state and serviceability limit state checks. If you do not input the increments of characteristic permanent loads, then the results might be not correct. In this case, in RCS program, in section program, we have to fill it in manually. In case of time-dependent analysis in IDEA StatiCa beam, all these effects are calculated automatically. Then I have explained the input, the possible input or type of input of the losses, and also the calculation of effects of pre-stressing. So we can go further to internal forces. Now from the picture here you see that it is the table to input the forces acting at ultimate limit state and serviceability limit states. But actually the effects of pre-stressing are already filled in and are disabled. You cannot change it because it is a result of the calculation. I prepared the effects of load in advance. In 5 days I have this table, so you can copy it to the clipboard and paste it into RCS program, and you will see the table filled in. We have a bending moment here. You see 3,375 kilonewton meters at 5 days, which is the effect of the self-weight at the ultimate limit state, including the factor. So if we specified 2500 as a characteristic load, which was in these action stages, you see here 2500, internal forces must be multiplied by 1.35, which I did here in this Excel file. So actually this difference is only caused by the load factor. There are no live loads here, variable loads, because we are at 5 days. So we can continue. We can see the reinforcement. Actually, we can define the reinforcement using several templates or using reinforcement, general reinforcement editor to define. We can define any reinforcement. We do not work with necessary areas, but real bars. Therefore, it is possible to apply all the checks or to calculate all the checks according to code. I will use a predefined template with a certain intelligence, I would say. This is smart template, and I want to have 6 bars number of the diameter 16 at the top, 4 bars of the same diameter at the bottom, 1 edge bar across the depth of the cross section. This will be diameter 10, and stirrups will be diameter 10 with the concrete cover 30 millimeters and stirrup distance 15 centimeters. This edge overlap will be 200, and I have it now specified in the cross section. I can switch off the dimension lines, and possibly I would also should also mention that you can save the reinforcement as a template. You see, create template. This is a possibility that the user will adapt the reinforcement based on his wish, and he can save the reinforcement as a template, and you can use it for different cross-section of the same time but with different dimensions next time, or he can share it with the colleague and so on and so on. Now we go to calculation control. Actually, by default we have the data or the checks which are necessary switched on, and I will switch on also the response, flexure response, which will be nice to see and will tell us more information about the cross-section. Actually, we call it visual design. Then we can go to results, and the section is calculated in nonlinear way, of course, and you can see on the first view that interaction is not satisfactory. All other checks are satisfactory at that time, 5 days. So we can go to interaction here, and we can see the results. It is 148% utilization. The program gives you all the information, what caused the problem, and also it tells you that the shear check is not satisfactory due to insufficient strength of shear reinforcement loaded by the combination of shear and torsion according to clause 6233 and 6323 of Eurocode. Then we can definitely go to Eurocode, study it more if you want, but I will go back to reinforcement and increase the stirrups. I will select the reinforcement and I increase the diameter of stirrup to 12 millimeters. I calculate it now, and you see that still my interaction is 102, almost 3%. So if I really want to make it satisfactory, I will decrease the distance of the stirrups to 125 millimeters. I calculate it again. Now we see that everything here is satisfactory, and actually this first state during pre-stressing is satisfactory. We have it designed. Now we can go to project summary sections. I skip report. It is quite easy. And what we see here is that I made a mistake. I did it intentionally, of course, to let you know that this should be also filled in. We have it checked at the time 28 days because that was the default when we started the program. And the program doesn't know what type of checks in which dates or ages of the concrete you want to make the design. So I change it to 5 days now, which is actually the same time as if you go to design member, construction stages, and we have this 5 days TP time at the time of pre-stressing. So now I have it specified correctly and I have to calculate it again. Now we see that the stress limitation in use is used to 127.5%. Actually, why? It is because we decreased the age of concrete, and that's why we decreased the strength of concrete at that time, at the time of pre-stressing. And as there is a very strict limit, I go to stress limitation now, and we see that it is the concrete fiber which is critical, index 7, it is this one, and it has stress 12 megapascals, and it should be minus 9.4. So the program tells you that clause 7.22 is not satisfactory, and we have to change the design. We should say that this stress limit is very, I would say, limiting, very low limit. It is 45% of FCK, and that can be avoided by calculation or by performing nonlinear creep analysis. This can be done in time-dependent analysis in our program for beam, but of course it cannot be done in the cross-section, standalone cross-section. So that's why we can hardly avoid or skip this check. We can do it only when we input the beam as a whole in IDEA StatiCa beam and run time-dependent analysis TDA option. So now we see that we have two big pre-stressing. So we have several possibilities. We can decrease the stress in the, here we can in action stages we can decrease this stress, but also we are able to decrease the number of strands, and I will do it. We can of course also increase the concrete grade, or we can apply the pre-stressing later in a higher age. So if we accelerate the hardening of the concrete, and we can input other equivalent age of concrete, which enables us to use higher concrete strength. But in my case, I select to change the number of strands to 6, and I calculate it again, and you see that we have all the results satisfactory, at least for this 5 days. 5 days. Now we probably want to design or to check the section also in 28 days when we apply additional superimposed dead load, and at infinite time in 100 years. So let me to go to sections, and I select the appropriate extreme, and here we have a nice button, copy extreme. And in that case, if I press it, then we can copy it, and here we can adapt it to 28 days, and that's it. The only thing which we should modify are internal forces, because we have no variable internal forces. So I go to this table again, in which I define some variable effects, load effects. You see, for example, 2500, 1800 for frequent combination, and I can calculate it, and I see that stress limitation is 106. I go to results, stress limitation, again concrete fiber in here. Let me to see the sections 20. I have it for 5 days. I'm very sorry, I made a mistake. Actually, I copied it into the extreme 1. So that's what you should not do. Let me to select the forces for 5 days again. I'm very sorry, and copy it here. Now I have it without the variable effects, and if I go to second extreme and I go to Excel and copy this with variable effects, check it, double check, okay, I have it now. I copy it to here, and now hopefully we go to sections, we get the results. I calculate it. Yes, both are satisfactory, everything is okay, and now we want to have the effects at 100 years, so it is good if we select the last extreme and copy the extreme. Then I change this to 36500, 100 years, and I calculate it once again. Now we have it, assuming that the internal forces and at 100 years are the same as in 28 days after superimposed dead load is applied. Now we can show some results. First of all, I want to show you the response for ultimate limit state. We have first extreme. This is at the time of prestressing. You can see that we applied quite big prestressing, which can balance almost 100% of the dead load. If we select the other extreme at 28 days, we already have some double bending, which I intentionally input, but also we see that my live load causes the cracks in bottom fibers, and if we go to 100 years, you can see the results, and I go to 100 years, then the results changed because even if we have the same internal forces, the results changed because of long-term losses. We can also see this in stress limitation, that the assumptions are a little bit different. We still have, I will go first to time of prestressing. You see again the effects of characteristic loads. Sorry, this is quasi-permanent because this is critical, but it is serviceability limit loads. We go to 28 days. You see that due to the losses we have different, and also applied loads, we have different distribution, and at 100 years we have even different, and in this case the cracks appeared. There is an assumption that we have concrete not effective in tension even in SLS combinations. If we go back to ultimate limit state to response, we should probably show the diagram, stress-strain relationship for concrete. It shows you most pressured concrete fiber and where we are. If we select other concrete fiber, we have different concrete stress, as you can see in this picture. You can also select the tendon. You see that our tendon is loaded on plastic branch, and also mouse pressured non-prestressed reinforcement is also very close to the plastic branch. We can see also resultant forces and 3D view, and that's what we call visual design. We can check everything which is calculated, including, for example, if we see the response, we have a lever arm calculated, and in shear we also get the lever arm. We see BW, the width effective in shear, and we can also identify the distances between. Here we have the cross position of resultant force in concrete in compression zone and position of resultant force in tensile reinforcement. So that's why we have here lever arm according to the code. I will discuss this lever arm and the parameters for shear design or shear check next time in next session of this Dutch concrete sessions. So I'm looking forward to explain how we do it and what is possible in our program. We can also see the torsion. The program calculates equivalent involved section automatically if you select here in reinforcement the stirrup effective in torsion. It's better to select one stirrup, because if you select all of them, then the program will could be I would say confused and would not find the equivalent thin wall section. The last but not least, I will show the difference between the response. Here we have response. You can see the stresses in steel. For example, here we can see the biggest difference. This is linear branch in non-prestressed steel. And if we go to interaction, we have it loaded. Part of the section, even plastic branch, this different color, and part has higher stress than in response. This is caused by the longitudinal force which we apply due to the shear force into longitudinal reinforcement. Again, I will explain more in the next session of these Dutch concrete sessions. Now I should probably show the last pictures of the PowerPoint presentation here. I mentioned in the live show that in action stages you can select also not calculate but user import an input. Now you can see that the tooltip is different. The initial cross-section is defined as total effects of characteristic permanent load, pre-stressing and creep and shrinkage of concrete. So this is intended for the user who doesn't want doesn't want the program to calculate it, but he wants to input it himself. So all the data is calculated independently, and you can input it via internal force acting on the component of the section. Component of the section could be, for example, a prefabricated part of the composite concrete to concrete section, or using plane of strain. You see a plane of strain or internal force. This is quite general possibility, but very time consuming. If I input here some moment, let's say 1000 kilonewton-meters, then you see that all this data is changed, and we calculate the strain and stress in each reinforcement and also in each component of the cross-section. Now we have one component only because we have solid section. Also the bars of reinforcement bars can be calculated based on this input, based on component initial, or can be independently specified as user import or input. Similarly, other data in the other tables. I'm not going to show it here in live show. I will switch back to calculate, because this is the way, I would say in 99% of the use. But sometimes if you want really to input the initial state yourself, then you can do it using this dialog. And it was done, for example, at Brno University of Technology by this associate professor Zich, and they made forensic engineering expertise in Slovakia. There was a structure which suffered some problems, and they wanted to retrofit the concrete columns. Originally they were not composite, but they made it composite, concrete to concrete. And these guys used our program, actually our BEAM program, to model the composite column. And they say that they didn't find any other similar commercial structural design tool with such capabilities and of the analysis methods and of the checks, as you can see in the testimonial. And here we have the result. This is the result of the original shape of the column, which originally was solid. And now we have, after the reconstruction, we have a composite section with additional composite part around the column with quite complicated stress and strains. And in this case, we can define almost arbitrarily the state of the stresses in reinforcement and in various parts of the cross-section via the dialog which I showed before. So that's it. I would like to finish this presentation and our webinar today by last picture summarizing all the checks for both ultimate limit states and serviceability limit states available in IDEA StatiCa. And now I would like to ask our support specialist Alexander to tell me if there are any questions.
No, there are no questions yet. So maybe
okay.
Later, right now.
Anyway, we have the possibility to answer by email. You can send us an email, or you can send the email to our reseller Emil Peltenburg, and we can answer your questions by email. So let's wait a little bit. If we have one, I can see some.
Yes, there is a question.
But I cannot.
What can people do if they want to recalculate bridges after 50 years?
Definitely, we have a possibility of the bridge load rating. This is not a part of this reinforced concrete section program. It is a part of BEAM program or our BIM program after import from, for example, CI engineer. But definitely we have an option to analyze old bridges and to calculate the rating. What is the rating of the bridge? Calculate the live load carrying capacity of existing structure. That's possible, but it is actually not part of this sectional program. Okay. Any other question? We can, if you are interested, then we can organize some webinar later. But actually, this first 4 sessions are already planned, so it would not be possible.
So the question was published, answered. Can you use bridge load rating in RCS? So
yes, but only in case that RCS is linked to a BIM program or BIM program, which means that if we use RCS to assess, to check the sections, but the data is filled in from Beam program or BIM program. So in that sense, the answer is yes and no. Yes, because when we import the data from the other program from IDEA StatiCa Beam, then RCS is used in bridge load rating, but as a standalone you cannot. Any other question?
No, not yet.
Okay. So then I would like to thank you for your attention and participation, and I hope that we will hear each other, or you will hear me in the next concrete session, which is approximately in 2 weeks. Thank you very much, and bye-bye for now.